All right. Um, so today we are going to continue our modern client-side defenses. So we talked a little bit last time about CSB. Today we're going to talk about CSB in a little bit more length. And I'm going to basically just give you kind of an overview of modern client-side defenses that you'll probably encounter if you end up building web applications at reasonable companies. If not, then you should totally encourage them to use a bunch of the things that we're going to talk about today. So let's get started. So really, like what I want to like kind of get at today is uh, I want to get to the point where we can think and kind of learn concepts and mechanisms that we can use to build secure client-side web applications. But like every time we talk about security of any kind of systems, we have to keep in mind flexibility, because right, like if the thing doesn't actually work, well, then we're not going to do the secure thing. And really what we're going to look at is like kind of this trade-off between flexible and security angle. And um, just this angle that I'm going to tell you about is largely coming from the way I've been doing research in web security. You're probably not going to read much about these trade-offs when you look up these different concepts, but I think it's something worth thinking about and kind of having in the back of your head when you're looking at these different mechanisms. So to start, what I want to do is I want to just like pull up the browser and look at what like a real website might look like, and I'm going to pull up here, let's say New York Times, right? So I loaded New York Times a little bit before class, and I can show you kind of like the bunch of things that it loaded. So this is actually in Firefox, and it's in Firefox um, with tracking protection turned off. And so it's loading a ton of things. In fact, if you look at how much data it loaded, well, it loaded about what, like 60 megabytes, which is actually a little bit ridiculous, right? So like when you're building these web apps, one thing that these people are clearly not thinking about is people who don't have access to um, this much bandwidth. So like third world countries and even parts of the US, right? Like it's pretty bad. And more importantly, what we're seeing is like we have tons and tons and tons of resources. In total, there were 368 requests made to load this mostly mediocre page, right? So okay, if we actually look at like even what the page has here, well, there are these advertisements here. If we say do an inspection, these things are actually pulling it are within a div. The div is loading content here from what looks like Google Ads, and the way it's doing that is it's using iframes, right? So okay, we have definitely content that's being loaded on New York Times from Google. The other thing that if we look at the top level, right, like this whole thing here, well, right below it is, all right, the inspector is not playing really nice, but this whole bit from here on downwards is also an iframe. It's loaded actually from New York Times. They're trying um, to make sure that like you can't access like their whole page unless you pay for this for more than like 3 times a month or something like that. Let me see if I can get this thing to highlight. Well, I probably can't. Okay, if we then look at the networking, like what has actually been loaded and what are the origins of these things, a bunch of these are actually from New York Times, but not all of them, right? So one is from DoubleClick. This is Google's ad. Some are from a.et.nytimes.com. Some are from a1.nyt.com, which maybe is still New York Times. Then ad services like google.com. Then we have this, I have no idea what that domain is, or Criteo, however you say it. Then we have serving sys. Then like whatever that domain is, bing.com, some CDN, which is kind of nice, right? So CDN is like where we're going to load a lot of content from because we want to scale to the like wide network. More CDN, something from fonts, Google APIs, more New York Times, and so on and so forth, right? So what's really going on is like we have tons of different players that are appearing on a web app, right? So like when you're building one of these huge web apps, right, you have the page developers, right? This is your team that's working on this. You have libraries that you depend on. So that I'm sure there's like jQuery there and something else that you'd use to help you build this web app. You have service providers, so things that actually bring up a bunch of data. So here we didn't actually look, but there's definitely like links to YouTube probably, and like Twitter and stuff like that. And there's data providers, ad providers, again, CDN. So this stands for content delivery network. And this is basically just a provider like Fastly or Cloudflare or Akamai. And their whole goal is basically just to have servers that are close to end users so that they can ship content faster than your web app could and scale to way more users than your one server or few servers can actually scale to. And lastly, the one that's kind of transparent is the network provider, right? Like, so when I access this web page, I do it through some network provider. That thing actually gives me, could potentially intercept any of this traffic and potentially give me something else if we're not serving things over HTTPS, right? So that's a thing I have to be worried about. Sorry, I have to like click a new tab because that web page is so distracting. Okay, so what we're going to try to answer today is these series of questions. So today is kind of like what I hope fun look at like what we really have on the web and how we're going to deal with these things. So we're going to try to figure out how we can protect a page from, say, ads or services, how to share data across origin, right? So even what we saw on this page, we had NewYorkTimes.com and NYT.com. Those are technically different origins. We may need to actually share data across origin. How do we do that safely? Then how do we protect one user from another's content? So on New York Times, there might actually be comments that other users can make. How do we actually protect one user from another, right? So this is kind of the classic XSS problem that we talked about last time. So we're going to look at how we deal with it slightly differently today. Then how do we protect a page from a library? How do we protect a page from a CDN, right? If the CDN has been compromised, how do we make sure that our page is still doing the right thing? And then finally, how do we protect against bad network providers? So we're going to answer all these questions with a bunch of different mechanisms. But we're going to start just by looking again at the same origin policy, right? So the whole idea of the same origin policy is that it lets us isolate content from different origin. So on this particular slide, I have a.com and an iframe to b.com, right? So the same origin policy ensures that I can't access the DOM of b.com directly, but I can communicate with b.com using post message in the browser, right? So if I have an iframe, I can send a message and the thing can reply back with another message. I can also communicate with a completely different server. So I can communicate with c.com. I can, in particular, load any JavaScript file or image from c.com and render it in or execute it in my a.com frame. But I can't look at, say, HTML that c.com might be trying to send me, or a JSON object, right? So just essentially like any kind of object, because that they're different origins. So the same origin policy says, hey, no, you can't look at these responses, right? So this was the HTTP response, same origin policy. Okay, so that was just like a one slide refresher on at least the DOM SOP, the one with and HTTP a response SOP, the ones that we really kind of mostly care about. The other ones are more esoteric, but they are important when you're actually like building serious websites. Okay, so why is the same origin policy not actually good enough? And by not good enough here, I mean both functionality wise and security wise. So we can start with a very simple case that it's not actually strict enough, right? So first, third-party libraries run with the privilege of the page. So wherever I may load a script from, that script has a privilege of the page that it's running in. So what that means is within a page, I can arbitrarily leak and corrupt data, right? How do we do this? How can, like, if you compromise a CDN and are able to serve users a bad jQuery, how can you corrupt or leak data contained on arbitrary pages? Let's go with leak. How would you do it? Yeah, so you can just access the data and you would leak it how? Exactly. Right. So like you could just send requests, right? So like you can either like use the XML HTTP request API or fetch API in JavaScript directly, or you can, and inject, image with URL that and the URL kind of containing or encoding the data that you want to actually send over, right? Great. So that's exactly right. So how should we actually isolate, or how should we try to isolate this code, kind of knowing the things that you know about the web so far? How would you go about, say, sandboxing or isolating third-party scripts? Ideally, let's just say, let's pretend that we can do whatever we want. What's the first thing that you would think of? Yeah, so like, okay, maybe sandbox would be great. Of the concepts that we looked at last time, like what does it mean to just to tainted values would be awesome too. Yeah, like I'd want all those things in the browser too. But yeah, frames are the things that we actually have, right? So frames are primitives that the browser gives us, right? These are nested execution contexts. So one thing that we can think or try to do is, put this code that we don't trust in a separate iframe, right? So this is kind of, if going back to our um, our isolation lecture, right? Like if we put the code we don't trust in a separate uh, process and only communicate with that process with message passing, suddenly we're in a bit better world, right? So that's a pretty good start, but iframes turns out to not be perfect, right? So in particular, we can't isolate user provided content from a page, right? So if I'm using an iframe to render user HTML, my claim is that that's actually kind of not great. Um, and we similarly can't isolate third-party ad in an iframe, and kind of for the same reason. So why are our iframes not actually so great? So we can totally place a third-party ad in an iframe, but my claim is that that's actually like alone not that great. So that kind of that's a really great question, and I'm asking it back. We totally can place it, but that's some things might not be so good if we do. So iframes can access some parent data. Like what? So if the iframe is cross origin, so sometimes, right? Okay, so like if we go back to our previous lecture, or even a few slides back, right? So here I have two frames, or like one frame, let's see, b.com that's embedded in a.com, right? So if b.com, let's say, is an ad, we know that it can't actually inspect the DOM of a.com, right? So it can't muck with the a.com page, right? The only thing it really can do, or at least the only thing that we've really talked about so far, is that it can send a message to a.com, right? So the ad should technically not be able to do anything with the top level page. But I think you're kind of getting at something. So maybe there's something more. So like, can it actually escape the sandbox somehow? And really, the answer is yes. And not in that it can like muck with the DOM here, but one thing that it can do is it can navigate, say, the whole page to b.com, right? So you can navigate this whole thing to b.com and make it look like a.com, so that, like I've navigated a top level thing. Now you as the user might not have noticed that we went from a.com to b.com, and now you might type in things that you shouldn't be typing in there, right? So to some degree, like this thing being this nested context, being able to navigate the top level context is actually kind of scary, right? Because we can do these kinds of attacks. Um, so okay, so that's not so great. So that's for the ad case. For the user provided content, well, if we just place it in an iframe, right? Like if all we're doing is serving our own content in an iframe and not putting it in a separate origin, then it's the same origin. So if that thing happens to have um, scripts that we haven't properly filtered, then it can just touch the outer DOM and do whatever it wants to do because it would be same origin. So anytime you're actually serving user provided content, you should serve it from a different origin. You just have to essentially manage multiple origins when you're running these kinds of services. So for example, if we look at, I don't know, let me pull up, I guess. Let's see, maybe let's just try it out. So let's go to YouTube and see where YouTube videos are served from. All right, let's just inspect this element. All right, so if we inspect this element, maybe we'll see that it's actually being served. Okay, so this one is actually served from youtube.com. Let me try to see. Okay, well, maybe not. Okay, so what I was trying to actually figure out, so I don't use YouTube enough to know anything about it, but if I send you an image, say over uh, over email, and you're using Gmail, well, what Google does is it takes the image that I sent you and puts it under the googleusercontent.com origin and serves it from that origin instead of google.com, because they're afraid that any user content can potentially be used to escape the same origin policy and kind of get at same origin data. And images are a little kind of weirder because really like you'd have to break some underlying sandbox, but any kind of like user content, they typically serve from a different origin than google.com. Okay. And people screw this up all the time. So like in the second case, the ad case, the navigating you to a bad website has actually happened to a real website. So a while back, in 2009, and I'm sure a bunch of times since then, the New York Times was actually serving bad ads. These ads were actually in iframes, but they didn't have any way to restrict these ads from creating pop-ups. So those ads was actually malicious. It presented, a pop-up that looked like an antivirus. If you weren't aware that that was actually a web page, not a real Windows window, you might have actually interacted with it. And that's kind of how they would get you to download a bunch of malware on your machine. Right. So like New York Times actually had to just tell users like, hey, please don't click on this until we actually sort this thing out and deal with these kinds of malicious ads. Okay. So that's kind of like one of the angles of the same origin policy is not actually strict enough, right? There's no way for us to say like, don't do these things. If you're in an iframe, the iframe is really not a lesser privileged context. We'll see how we do that in a little bit. But before we do that, I want to talk about the other angle, which is flexibility. So it's not only is it not actually secure enough, where it's not actually flexible enough. So like a bunch of times we end up, having to do all kinds of kludgy things to build the rich web applications that we want to use. And one of those things is that we can't read cross-origin responses, right? So what if I actually want to read cross-origin responses, right? This is a pretty natural thing. So for example, weather.com or, NOAA might actually have weather data and I want to build a web app. There is no way for me, at least with the same origin policy alone, to get the data client side in the browser and display it to my users. right? I essentially have to like do all of this stuff server side and kind of keep copies of this data on my own servers. So what do people actually do? Well, they just actually bypass the same origin policy. So this is what JSON-P really is. So JSON with padding is basically a way of getting around the strictness of the same origin policy to fetch cross-origin data. The way it works is if you want to fetch data from, say, provider.com and you're on example.com, what you do is you inject a script element. So here we inject script source, provider.com, and then we give the path, say, get data. And then in the query parameters, we essentially pass back a signal to the server to say, like, hey, when you give me the script, so whatever script you end up shipping to the browser, that thing should call function f. Function f, I've defined on my page to handle any data that comes from your server. So what provider.com then will do is they will basically send a very simple JavaScript file that just contains a function call. It calls function f, the function that we told it, and then it passes an argument containing the data to this function f. Right? So this is like one way to get around the same origin policy to get data. So let's actually look at what this really looks like and work through it, because I think it's actually kind of interesting despite the fact that it's a little bit terrible. So let me grab the iPad and chat. So here we are at example.com, and what we want to do is we essentially want to, again, just fetch some data from provider.com. The same origin policy lets us perform a request, but we can't look at the response, right? So what do? Well, if we want to fetch data, we include a script source to provider.com/get data. Callback is f, right? Okay, great. So somewhere else before this, I've actually defined function. Again, I have a separate script where I define function f, data. And let's just say that all we want to do is print this data out with an alert. So alert data. Okay. So, okay, this is our script. It defines function f. Then we insert another element script. This performs a request to provider.com. Provider.com sends us back the script that we're actually going to execute. This script, all it does is it calls f with, let's say, x55, y42. Right, so this is the script from provider.com, and now we're going to essentially call this function that we've defined earlier with x55, y42. Right, so this works because the same origin policy doesn't prevent you from sending scripts cross origin and just executing those scripts directly, right? So that's one way for us to just get data cross origin. Now, the question I have for you is, why is this a terrible thing? Right, so people sometimes do this to get cross-origin data. And my claim is that this is like a very bad thing for the world. Yeah, great. Well, like all we want is data. And to get data cross origin, we have to execute a script provided by provider.com. Now, I don't know about you, but I don't want to execute arbitrary scripts that are coming from places that all I want is data, right? So this is going back to our whole previous thing where where data is treated as code. This is like essentially what we did. So if provider is malicious, we're totally hosed. If it gets compromised, we're totally hosed, right? And all we really wanted to do is have data, right? So this thing could have done all kinds of evil things here. There's no way for us to restrict this piece of code to just calling f with data, right? So like now we've included provider.com in our TCB. Okay, so that's one bad reason. Why else is it bad? and like one way to look at this is maybe it's not necessarily just that bad from the example.com angle, but it could be bad from the provider.com angle. Right? So why is this not a great thing for provider.com to do? So there's always a potential for denial of service, for sure. So their code with data will be running in an untrusted web page, right? So the other thing is, how does example.com authenticate to provider.com, right? So that's also pretty tricky for us to do. So it like really comes down to two things, right? So provider data is trusting this example.com with whatever data they have, no way to do anything about it. And really like this comes back to a kind of CSRF attack where like I, as a provider.com, essentially have to do weird kludgy things to figure out whether or not I should send data to this particular and this particular browsing context. And the way to maybe try to do it is again kind of like have context. So when you send a request, get data, with the query parameter CV is equal to F, you might also send some token saying that actually like this is okay. But it gets really hard to get this right. And what happens is a lot of websites just expose data through these JSON-P endpoints that they otherwise wouldn't to, and they do so kind of like in the public. And again, the other maybe more serious one is that the page is not protected from the provider. So the provider can execute arbitrary scripts. And that's really scary. Okay, so let's go back again to the same return policy is not enough security-wise, and how we're going to, we have a question. So do websites like banks or such not really work with third-party websites? That's a really good question. So they do. They use some of the techniques that we're actually going to talk about. The reality is that third-party kind of collaboration still sucks. So if you've used mint.com, which is supposed to aggregate data from different banks and tell you where you're spending money. I don't know if they still do that, but they used to do that. Because the same origin policy is so strict, and even like things like this CORS that we'll talk about that's meant to like address some of these problems is not good enough. Like what happens is these websites sometimes ask you for your like bank password, which is frightening because if you give mint.com your bank password, it doesn't have to just read your data. If it gets compromised, they can do all kinds of other things besides read your data to give you a pretty graph telling you where you're spending money. So like the unfortunate bit is it's not great. And there's a lot of protocols that you essentially have to implement. Most of the time what happens is you create these complicated websites with a bunch of iframes, and there's like a protocol, message passing protocol across these different iframes. Yeah, for sure. Good question. Okay, so what we're going to look at in the rest of this, the time that we have, is these different mechanisms that either try to tighten the security of the same origin policy or make it more flexible, but in a safe way so that we don't have to use things like JSON-P. And these different mechanisms that we're going to talk about address kind of one of the questions that I've outlined before, which is kind of dealing either with a malicious ad or potentially compromised CDN or things like that. So let's get started with the iframe sandbox. So the idea behind the iframe sandbox is that what we want to do is restrict the actions that an iframe can perform so that iframes essentially become an isolation primitive and not just another nested execution environment, right? So the idea is we're going to set the sandbox attribute when we create an iframe. So when we create an iframe, we're going to do iframe, and they then say sandbox. So this creates a sandbox iframe, and what that does by default is it disallows JavaScript and triggers from being executed in this iframe. So this iframe can't execute JavaScript, it can only render HTML. This is pretty awesome, right? Because if I have user content, suddenly I can put it in one of these iframe sandboxes, and even if there is a script, the browser won't execute that script, right? So that's pretty sweet. It also disallows form submission. So if there is like a button, you can't convince the user to click on the button and exfiltrate that data. You can't submit forms by default. It also disallows pop-ups. So like the example that I had earlier of New York Times getting owned by a malicious ad suddenly goes away because a malicious ad can create a pop-up to phish users into downloading malware. It also disallows navigating the outer page, the embedding page, right? So we can't navigate to a malicious page and convince the user again through phishing to do something that they otherwise wouldn't. And finally, these iframes, these sandbox iframes, they have a unique origin, right? So it's a different origin from every other origin that you can think of. Basically, every iframe sandbox has its own unique origin. And what this basically means is that you don't have the ability to store any cookies or use any of the other HTML5 storage APIs, right? So like nothing is, because like once the sandbox goes away, you can't create another iframe sandbox with the same origin, right? So it's essentially like a temporary sandbox that you can run a bunch of untrusted content in. So this is pretty awesome. So we're going to actually look at how to use this. And oftentimes, these things are a little too restricting. And for real web apps, we're going to need to make it slightly more flexible. And the way we do this is we have essentially a list of attributes that we can attach to the iframe sandbox. So for example, when we create an iframe sandbox, if we say allow, we can pass allow scripts. And this basically lets you execute scripts in the page, right? So now suddenly it's not just HTML that I'm rendering, but I'm allowing that that piece of code to also execute arbitrary scripts. I can also allow forms, right? Because this iframe, I need to actually allow submit forms to different pages. I may want to let it actually create pop-ups. I may even want to let it navigate to the top level embedding page. Right. So all these things are things that we can allow the iframe to do, but we have to explicitly put it in this list because by default, it's actually a lockdown sandbox. And we can even allow for the iframe to take on the origin of the URL of that frame, right? So if we do iframe source example.com, if you also specify allow same origin, then that thing won't get a unique origin. It will get example.com as the origin, right? And sometimes we'll need this, and we'll see at least one use case where this is necessary. But it's also it can be safe. You just have to be a little careful because this combined with the allow scripts brings us back to just an iframe. Okay. There are a lot more things than the ones I've listed. There are all kinds of values that you can use with the sandbox attribute, but I'm not really going to go into them. I think you should just take a look at the HTML5 spec for the sandbox attribute for iframe sandboxes. If you're interested in these kinds of things, it's a worthwhile document. Just even to get a sense of like what these things are written like and what the browser is doing internally when they have to implement these things. Okay, so we have some sense of like what these iframe sandboxes look like. What we're going to try to do is run content in iframes with least privilege, right? So like we know how to build secure systems. Least privilege is one way to do that. And our idea here is to put untrusted code in an iframe sandbox and only give it privileges that it actually needs. And from this, we can build more complicated systems by essentially just building a page that contains a bunch of these iframe sandboxes and giving different sandboxes different privileges to, at the end of the day, compose our big, nice, beautiful web app. So let's look at one super simple thing of how we do least privilege, and that's running or allowing users or having a Twitter button on our page that lets users, I don't know, follow or share this particular page with the rest of the world. Right. So this is the Twitter button, and let's look at how Twitter is going to tell us to embed this thing. So like if we want to actually embed a Twitter button on our page, what we're going to do is let's go to the Twitter page. So here it is. This is publish.twitter.com. So what I'm going to do is just scroll a little bit down, and basically what I want to do is I want to embed Twitter buttons on my page. Okay, great. So now they have a bunch of different awesome options. Cool, 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 cool. So I'm going to do the simplest one, which is the share button. So that's all we need. Look at this. This is awesome. So Twitter even copied the code for me, and it's showing me this beautiful thing that says like, look at this thing. So copy this code. Let's copy the code. What do you think this code actually looks like? Like it's looking pretty good, right? Yeah, it seems just like a hyperlink, right? Like, which is exactly what we want. Well, I don't know. Let's go to pad.riseup.net. There we go. Okay, so I'm going to create a pad for one day just so I can paste that script. Okay, here is what that copy actually gave us. So it gave us a nice, beautiful a tag, right? So this is just a link. And then it also included a script. This is great, right? So it's not that we're only like embedding a button, we're embedding a button plus this thing. And maybe that's okay, right? Because like otherwise this would just be um, a link that is not styled. So look, like what they want to do is they want to pull in this widget, right? So like maybe all the script will do is, make this pretty button looking thing. So like, let's see what that code actually looks like. Cool. So what is this code doing? It doesn't stop. It's a little way too long, right? So this is pretty frightening, right? So like what they're actually telling us to do is embed a script. What's the problem with embedding a script? Right. So like this script could do a bunch of things. One of those things that it can do is what Felix is saying, which is track everything about the page the button is embedded on. We have no idea what that script does, right? And in fact, the script can totally change underneath us, right? So if platform.twitter.com gets compromised, the attacker can ship a very different widget that does very different things, right? So we're completely trusting this thing, and that's super scary. So what should we do instead? Well, we should maybe go back. Let me go back to the Twitter page. So with like a little bit of Googling, I got this other page, which is, hey, you can load a button in an iframe. So the idea is this is what the normal thing looks like. The JavaScript example looks like this, but you can also have an iframe example. So you can do iframe and then say source equals platform, blah, blah, blah. Here is the width, the height. And basically all we're doing is pointing to a Twitter page where they can go style the things however they want, right? They shouldn't populate or execute code in our page because A, like that could break the styling of our thing, but B, it can do all kinds of things we don't want it to do. So, okay, let me look at this question. So Ryan asks, the ease of deployment by using the link could end up being a vulnerability. Yeah, like a super duper scary one, right? Like, and to be completely honest, like it's kind of unethical that they're starting to make it look like this just simple link when really it's a link plus a script, right? They should make it very clear that you're loading a script and you're trusting Twitter when you're doing this. And I don't know what the script actually does, but I'm sure to whoever said earlier, it's definitely looking at like what you're actually doing on the page. This is kind of how ads really work. They look at what the hell you're doing and what's actually on the page, because that's how they make money, really. Okay. So one more question from Kimia. So, but theoretically, why would websites like Twitter do that? Uh, well, they honestly do it because like one reason is better engagement, but the real reason is money, right? The reason they do anything is at the end of the day, these companies try to track users to figure out what they're looking at so that they can serve them better ads so that they can then make money off of ads because they're better at serving ads than other people. And honestly, like, look, embedding a script like the way they did is much easier than an iframe, right? So like that thing was pretty nice and clean. I don't have to deal with iframes and where I position iframes and all these other things. And to Felix's point, because 99% of users don't care about this kind of thing, that is no longer true. That was true, but now we care about privacy. And we also have regulations. So all these kinds of things are actually changing. Okay, but let's not get into that. We can talk about ethics and policy and all this stuff later in the class. What I still want to talk about is even with this iframe approach, right? This is still not good enough, right? Right. And the reason is exactly the reason that we saw earlier, which is like if this thing gets compromised, it can still navigate my top level page and it can create pop-ups and do all these other things. So what should we actually do? Well, we should use the iframe sandbox. Okay, so we're going to use iframe sandbox. And what we're going to do is we're just going to start with the initial attribute sandbox without any of the values and then give this Twitter button whatever permissions it needs to do its job, right? So we're going to start with an empty list here, and then we're going to add these individual things. So we're going to allow same origin, we're going to allow scripts, we're going to allow pop-ups, and allow forms, right? So this is from somewhat a while back, but I think it probably would still work. Now, why do you think? Well, okay, let's before we think we try to reason through why we may need all these things. What I want to look at is allowing same origin unsafe in this particular case. So, right, what does allow same origin actually mean? Well, it just means that when we embed this iframe is not going to have a unique origin, but it's going to have the origin of platform.twitter.com. Right? So is that actually okay or not? Richard says it's not. Why not? Ah, okay, great. So because Twitter could access our cookies, can Twitter access our cookies? Platform.twitter.com, which cookies can it access? Right, so platform.twitter.com can only access the platform.twitter.com cookies, right? And any subdomain of that, right? So that's totally okay, right? Same origin policy says like, look, twitter.com can access twitter.com cookies. That's cool. In fact, we actually want this, right? So if I'm logged in a separate tab into twitter.com, the whole point of clicking on this button is for me as Dan to reshare this whole thing, right? So like if this button doesn't know who I'm logged in as, it doesn't know how to reshare things, right? So it would basically, clicking on the button would direct you to a page where you have to log in and then carry out whatever retweeting or whatever the thing, the button intended to do, right? And it's kind of like for the same reason, this is like why we need all these other things, right? So we need scripts because actually I may not be logged in. So when I click on the button, what this thing will try to do is get me to log in. And to do that, it also needs to create a pop-up. And in fact, it also needs to submit forms if it does that, right? So if we, I don't know, maybe this will work. If I click on this button, there we go. So it says like, hey, you want to log in first, right? Because I'm not actually logged in. Whereas if I was logged in, it would show a very different thing. Okay. So Adam asks, would allow same origin permit them to track your page view of parents page even if you don't click share? Yeah, so that's a really good question. So iframes have access to a window object, which um, essentially leaks information about what frames or the origins of frames that are around. So to some degree, yes, they can kind of see what page they're embedded in, but not more than that, really. So they can definitely track you, but with a much more limited degree than they would if you were actually embedding the script, right? Okay. Any other questions on this before we move on? And to be clear, actually, sorry, to Adam's point, that this has actually nothing really to do with all the same origin. They would be able to look at the frames object, even if it was a unique origin, because that's just a JavaScript thing that we can do. So how robust is the browser's effort to enforce the same origin policy? It's actually pretty reasonable. I'm very biased to Mozilla because I know the folks who implemented kind of the core bits of the same origin policy. So their whole approach to implementing the same origin policy is very robust. Like they have principal kind of security mechanisms from kind of the academic world. What they actually are using it is called capability, like object capability model, which we're not going to talk about in this class, but I'm happy to talk about in section or office hours or things like that. And honestly, Google's is pretty reasonable too, though I think their JavaScript engine allows more sharing than I'm normally comfortable with. But I mean, like they have a very serious team, so they've gotten all the kind of process isolation really tight. So I don't know, like I'd put them on the same like equivalence bar of like really good. If I were to like work for an industry security team, it would be those two places because they're doing good stuff and they think about these things really hard. Other questions? All right. So we kind of have some sense of what iframe sandbox looks like. Now let's use it for one more thing. So we looked at the Twitter button. How might we use this for, say, our personal blog, where we have user content, like the posts, blog posts that contain bodies that contain HTML, and author names that may also contain HTML. So like normally we'd have essentially template files that look something like this, where essentially just splice in the author and the body with some kind of escaping that might be provided by our templating framework. What's wrong with this? You've seen this a few times by now. Like if post body is untrusted, what goes wrong? Yeah, exactly, right. So we have our classic XSS bug, right? With iframe sandbox, how can we load this content in a safe way? Well, one thing we can do is we can create an iframe sandbox with this source doc instead of source attribute, and essentially just paste in the HTML that we want to render in this iframe. So here would just be div class post, iframe, and so forth. Like obviously somewhere here we'll actually have to like have styling sheets and things like that. So you may want to be a little bit more flexible, but we can kind of render untrusted content in this way. Now, in practice, if we're going to actually try to do this, we realistically will need to allow scripts for any sensible blog application. Why? I guess this is a totally made up blog application. Why do you think we may need scripts? Well, okay, so there's I guess different reasons, but like if we think about a blog, right? If we have a post, in that post you might have, say, a commenting system at the bottom, right? You may need to have a nice user interface there. That means having to execute scripts. You may want to track who's reading this particular post, may need scripts for that, all kinds of reasons, right? So like in practice, like getting away without scripts is kind of hard, though I think it'd be fun to try because we've managed to do this a while back without this whole like infectious script disease that we've caught on. Now, do we need the allow same origin on these kinds of user provided content iframe sandboxes? Or rather, like, is it safe to attach that to this kind of content? So exactly, right? So like it's not okay because this is just content that we're executing inline. So it would take on the origin of the embedding page, right? The only time that this is actually okay is when it's cross origin so that it can't modify the page. Otherwise, you kind of get no benefit from having this thing running in an iframe sandbox to begin with, right? So like we really want it to be cross origin and not allow same origin. And realistically, if all we're doing is rendering a post, we shouldn't need to access storage or things like that, right? And if we really do need those kinds of things, one thing that I encourage you to do when you're building these kinds of things is just have a message passing layer between your iframe and the outer page, and like have the page do those things on behalf of this sandbox piece of code, right? Like most of the time, it shouldn't need to do all kinds of weird things. So you should be able to like write a pretty thin layer that intercepts whatever the thing might actually need access to. Okay. So we have some sense of what iframe sandbox looks like. What are some limitations that you can think of with what iframe sandbox as we've described so far? And limitations here can be both, right? Like flexibility and security, right? Like really, it can be on either of these dimensions or maybe even dimensions that we haven't talked about. Rather, can you think of applications where you'd like to build, but this thing is not good enough? Kind of like we've been like going through the path of we'd like to build these kinds of applications, but the same origin policy is not enough. Now we have the same origin policies and iframe sandbox. What else can we not build so well? Well, okay, I have an example for you. Suppose you wanted to build a password strength checker, right? So like we have a strength checking library. We don't necessarily want to trust this thing because, well, it might be doing fancy graphics. In this case, the graphics is not necessarily that fancy, but we don't necessarily want to trust it to not leak our password. We just want to like let it evaluate our password, in whatever strength measurement it may have, and give us like, a temperature reading of like, this is a strong password or a weak password, right? So in this case, I have a page a.com that embeds a password strength checking widget from, b.ru, right? And like the guarantee that we would really like when we're building this application is that, sending this thing the password can't possibly result in that password being leaked to b.ru or any other website, right? So if we try to use the iframe sandbox, right, this is not actually going to stop b.ru from exfiltrating the password, right? b.ru can use APIs like XHR or fetch to write the password, right? Send it over the network to arbitrary endpoints, right? And it needs to execute JavaScript because that's how it's going to check the strength of my password, right? So like, how do I give b.ru my password without, having to trust it not to leak this particular thing? And really, like, we can reframe that question as, can we limit the origins that that page can actually talk to, so that it can't leak my sensitive data to origins that I don't trust, right? So can we restrict it to only leaking to trusted origins and having some finer grain notion of least privilege, right? So this is where CSP comes into place, and really, like, when we think about this as information leakage, it kind of is really tied to code injection too, because one of the nice bits about code injection as an attacker is that I can leak a bunch of data, right? So if we can prevent the attacker from leaking a bunch of sensitive data, we've kind of won that game, at least from that dimension. Okay, so this is where CSP comes into play. And we've talked about CSP before, but we're just going to rehash it again because it is actually a pretty powerful mechanism, right? So the idea of CSP is to restrict resource loading to a particular list. And essentially, in doing so, what this means is that that page can only talk to the origins named on that list. And what that means in turn is that you can only leak data to those origins, right? So if you can only if you specify the list of origins that you trust, you're only going to leak to those origins. So that's fine because you already trust those origins because, for example, you may be loading scripts from those origins, right? And kind of the way CSP works is whenever you send a page to the browser, you send a CSP header that contains these directives that specify whether or not you're from where you're allowed to load different kind of content, right? So here we have a CSP policy that says you can load from cdn.example.net. You can't create any frames. This is what the child source is for. And you can't have plugins. So this is what the object source says, right? But you can't load all kinds of things from cdn.example.net, just not create any frames or plugins. Okay, so what this basically means is we can leak to the CDN, but that's okay because the CDN is already in our TCP. That's where we're loading scripts from. Now there's tons of directives, right? So there's a directive specifying where you can load scripts from, which origins you're allowed to perform network requests to in JavaScript, right? So that's XHR or fetch, where you can load fonts from, where you can submit forms. We already saw where you can load frames and workers from, where we can load images from, so on and so forth. So this is kind of from the spec, a screenshot I took earlier today. This thing has gotten mostly out of hand, but there's a lot of knobs you can turn. And that's to some degree good because you can control where your website loads content from and resources from. It's also bad because we screw this up basically all the time. There are special keywords to be aware of. So for example, none basically says we can't load it from anywhere. So it matches nothing. Self matches our own origin. And then we have escape hatches for a bunch of different things. The most prominent ones are unsafe inline and unsafe eval. And their kind of whole thing is, well, it will take a while for web pages to actually use CSP by specifying all these origins. So what we're going to do is allow web pages to use unsafe inline to execute inline JavaScript and HTML pages until they can move it out. And we'll even allow unsafe eval, but force you to specify that you're using a eval because, again, that could potentially lead to code injection attacks. And the, of course, ugly bit is we're going to let you load this kind of content from anywhere. So this is essentially turning off and putting every origin in that allow list. Okay, so how does CSP help with XSS? Well, if you list the places you can load scripts from, we'll only execute code from those scripts. And the only thing we have to be worried about is inline scripts, but by default, these things are disallowed. So if we don't use the unsafe inline, then by default, like, we're good to go. In practice, things are a lot more complicated. And to be completely frank, trying to build like even a simple website that loads fonts from Adobe that does very few things gets really gnarly to actually get right. So if you're going to go into the real world building web apps, good luck. Okay, so again, like this is pretty hard. Unsafe inline is the thing we use. This is a problem because it kind of forces us to give up on the security kind of ideal guarantees that we would get from um, from specifying the origins that we want to trust. Kind of as another escape hatch of like, well, we can let you load inline scripts. And it turns out that it was actually hard for web developers to move out all their scripts out of pages. So CSP added these script nonsense, script hash things that basically say like, hey, you can load scripts that are inline if they have a particular hash, or if the page has a particular nonce and the script has a nonce. If these two things match, you guess the secret right. So nonce is basically just like a token in CSRF. So if you provide that, then we'll execute your script, no problem. Now, obviously, these are kind of a little gross. You should always use hash because that actually specifies the script. You don't have to just guess this token, but it's a way of trying to move the needle up. There are other things that I guess I keep like hammering on, that this is like really hard to get right. If you figure out how to do this, like you'll have a really nice startup that you can then sell off for a bunch of money, or make the framework open to everybody else so that they can also use CSP. But basically for really large web app, this is really hard to do, to the point where CSP even has ways of phoning home saying like, hey, you screwed up the policy. And you can even like ship a CSP policy that's in report only mode, so it doesn't enforce, it just basically like lets you over time figure out what the CSP policy is for your web app. And if we look at something like the New York Times, right, like that thing loaded 368 resources, just I think scripts like that's a lot, right? So trying to figure out exactly what my policy is for a big web app is super duper hard. Okay. What I want to briefly look into is how CSP is actually used in practice, because despite all those amazing directives, only a handful of things actually dominate the usage. So I have here a graph for measurements that we did a couple years ago. So this is a little old, but the kind of sentiment is mostly the same. And I bet if we were to rerun the numbers, it'd be more or less the same, with maybe one or two more directives being in the top 4 or so. So let's look at these directives and see what they're actually for. So the first one that we're going to look at is the frame ancestors. All right, so the frame ancestor directive basically specifies how the browser, or whether the browser is allowed to load this particular page in an iframe. Right, so like when I ship the frame ancestor directive with my HTTP response, it tells the browser like, yep, you can actually like load this particular page in an iframe, or you can't. Right, so why might we actually want this? Like, what problem is this actually solving? Okay, so like what I'm going to encourage you to do is create a very simple page when you get home that embeds google.com, and you'll see that google.com actually doesn't let you do that. The reason really comes down to this other class of attacks that we didn't really talk about, called click tracking. So the idea is like, we don't want to let origins that we don't trust embed us as an iframe. Because one of the things that you can do with iframes is you can essentially make them completely transparent. So here, what we have is bestgameever.com that embeds twitter.com essentially at the top level. You just can't actually see it because it's transparent, but the user actually, when it clicks on buttons, it will be clicking on the Twitter page. And I can get you to delete your Twitter profile by just aligning that iframe in just the right way. So you'll never actually see this. You're clicking on what looks like my game, but you're actually clicking on the Twitter button that's embedded in this iframe, right? So does that kind of make sense, or should I go through what the protocol really looks like? Well, okay, so here we were allowing it. The whole idea of using this header is, if say best game ever tries to embed us in a iframe, so have script, iframe source equals Twitter, com. So this performs a request. Now, if I didn't want to actually let you embed me, what I would send is a response. So this would be a normal HTTP response, but it would contain the CSP header that says, let's say, frame ancestors, same origin. So this would only let twitter.com pages embed twitter.com responses, and the browser would basically disallow you from including this thing here. Now, obviously, like this is making up for the fact that the server can't quite figure out who is making this request and who is trying to embed this particular page in the browser, right? And this kind of goes back to our CSRF problem. So this is essentially a CSRF problem because the server can't distinguish who's trying to embed this thing. If it could, then you can imagine not even sending that response. Like, why bother sending a response that can't actually be, rendered? But we're making up for, a lost, broken web. Like in the future, you should be able to completely avoid using frame ancestors by just using the site metadata that we talked about last time. Okay, what about the other top one? So the report URI is the one that we use to, again, just phone home telling our server like, hey, this is where like the reports should be sent when we fail to get the policy right. The other two are upgrade insecure requests and block all mixed content. So to answer those, to understand what those two things are doing, we need to understand what mixed content actually is. And you might have heard about this from lots of buzz that's been going on around the web. So the basic idea is if you have a web server, it's pretty common for that web server to not only host content over HTTPS, but also do it over HTTP. So the UCSD web server did this. It might still do this. I periodically check. So you would be able to actually visit http cscweb.ucsd.edu, and it would happily give you back a response that contains the actual content. Now, why is that bad? And while you answer that question, I'm going to try to see if it's still doing this. Okay, injection from where? So let me So here I performed a request actually. So let me show you what I did. So here I just did a curl to cscweb.ucsd.edu. This web server clearly listens on port 80. It gives me back an HTTP response saying like, hey, this thing moved. It moved to http csc.ucsd.edu. Okay, then I make another curl to csc.ucsd.edu. This thing tells me, hey, this thing moved to csc.ucsd.edu, but over HTTPS. Right, so that's much better. Now, the problem is, I as the attacker, and here the attacker is a network attacker, I can intercept this thing, right? This thing is not encrypted. It's over HTTP. It's not authenticated, right? So what I can do instead is I can get you to visit, evil.ucsd.edu and or just inject whatever scripts I want, because I can do that, right? So like what they should actually do is not even reply back with any HTML. The csc.ucsd.edu actually is much better in only responding back with HTTP, but not HTML content, right? So network attacker can inject their own scripts. That could be pretty bad because those scripts can do all kinds of things that would look like they're coming from csc.ucsd.edu. So I guess I gotta email some folks again. Okay, so the other two CSP directives that we saw, the upgrade and secure requests and block all mixed content, they basically help with this migration from HTTP to HTTPS, right? So they rewrite HTTP URLs to HTTPS before making a request. So on big web pages, you'll have a bunch of URLs that are still HTTP. If you sent your page with the CSP header that says like, hey, upgrade and secure requests, before the browser makes the request, it tries to actually fetch it from HTTPS, right? And if you think that you've gotten your rewrites correct, right? So you're not expecting your page to have any HTTP URLs, then you can instead specify block all mixed content, and that would basically disallow the browser from loading any content over HTTP, which is essentially what we want, right? So this is kind of like the first one is essentially one way to help you migrate your web app automatically by like taking advantage of the browser doing something on your behalf. The other one is I finished my migration. Now please don't load anything over HTTP because everything should be over HTTPS from my web server. And we can make this stronger by essentially telling the browser to only load things over HTTPS from the point from in the future, right? So what we saw with the request that I showed you with curl is that if we respond with over HTTP, the network attacker can strip all these HTTPS URLs to be HTTP. As long as your server keeps serving things over HTTP, doom happens. The idea with HSTS, so this is another header that you can send to the browser. This basically tells the browser like, hey, from here on out, you will never visit this web page over HTTP again, right? So if I've ever made a connection over HTTPS to say csc.ucsd.edu, this thing should only serve things over HTTPS. Your browser should only make connections to HTTPS from now on. So now if we look back at our piece of code, we'll see that, let's see if csc.ucsd.edu actually does that. So let me, let's do this. Let's see, so CLS handshake, HTTP U1. So this is not so great. So we're not actually sending the HSTS header. Let's see if google.com will do it. And this might be www. Now let me do, okay, this is kind of ugly. All right. Oh no, give me the, okay. Set cookie. Okay, I guess for some reason not doing it either. Either that or curl is not displaying this. Yeah, okay, well, really? Okay, weird. Google should be doing this. But anyway, so the idea of this header is, again, only connect over HTTPS from here on out. It's possible that because they know I'm making a request with curl that they don't care because curl has no way of enforcing this. Okay, the last two things that we're going to look at are SRI and CORS. So SRI, or sub-resource integrity, kind of came about because CSP and HSTS are actually not enough for dealing with some of the other attacker models that we looked at, right? So suppose we're loading code from a CDN, right? Today we'd have to, even if the CDN is serving content only over HTTPS and does have sane CSP defaults, we might still be loading a library that has been replaced by an attacker that might say have compromised this part of the CDN, right? And again, HTTPS has no way of addressing this because all it gives us is an encrypted and authenticated channel. It doesn't say anything about the thing that we're loading. So the idea with SRI is to actually try to deal with these attacks that we're actually seeing in the wild against different CDNs, right? So one of those was Max CDN, where they were actually, where one of the CDN administrators or engineers was actually backdooring one of the libraries that was being sourced through Max CDN. So the idea with SRI is that you as the page developer, when you're shipping a page to the browser, you can specify a hash of the script or say style sheet or whatever other resource is, right? So like when you're in this case, say specifying, please load a style sheet from site 53.cdn.net. Well, what you're expecting is the thing that server should send you is to have this particular hash, right? And if the hash doesn't match, then we should be, raising all kinds of alerts saying like, this thing that we tried to load is actually different from the thing that we got, right? And we have this, we can do this for style sheets, but more importantly, we can do this, well, I guess as important, we can do this for scripts, right? We care about style sheets because they can also execute a script, right? So like a thing that you should do when you're loading, say, jQuery from, jQuery.com, you should actually specify the hash of jQuery. So then like if, jQuery.com gets compromised, which, it has, then you know that your page won't be executing just bad code that could potentially get your users to download malware or kinds of other things. So Wesley has a question: is that why sometimes download sites also provide like an MD5 hash along with it? That's a little different. That's for you checking yourself offline the thing that you download. I'm not sure if SRI has implemented this for actual downloads, but that one of the plans was to actually add these hashes for any kind of content, so that when you download it, you know that you downloaded the right thing. MD5 is super duper broken. If anybody tells you to check MD5, they're probably doing something shady. And we're going to have a crypto assignment where you mess with MD5. So you should use something like SHA-256. Okay, so what happens when the check fails? Well, there's really two things that we can do. So the default one is the browser reports the violation and doesn't actually execute that piece of code. In the case of JavaScript and CSS, for other things, it just won't render that blob. If you have a more fine-grained policy, so you can specify how the browser should deal with this, you can, for example, say, okay, I'll be happy to actually execute that thing, but tell my server that I've executed that thing. This may happen when you have really big websites, and again, you're trying to migrate things. In practice, this is what you want. Anything else, not that great. Now, the last thing that I want to mention about SRI is that there are multiple hash algorithms. So you can use SHA-256, SHA-512, so on and so forth. And really the reason we have this is over time, hash functions break. For example, MD5 that was mentioned is actually broken. And we may start with MD5, but over time we want to actually migrate away from MD5 and use stronger hash functions to not break all the websites. We allow page developers to specify different hash prefixes and hash algorithms to use. And over time, you can imagine that these things go away as they're broken, but this is a slow process. It's a human process. So for a few years, we'll probably still have broken things on the web. Okay, last one, and this will take maybe like 2 minutes, is CORS. So CORS addresses one of the flexibility angles of the same origin policy, and really it's kind of a response to the disaster that is JSON-P, right? So the idea of CORS is that a server can specify the origins that are allowed to inspect a response, and then the browser can look at that CORS header and basically let that particular context inspect a response or not, depending on what's in that list. So for example, if we're Amazon.com, Amazon or like New York Times, you already saw, they have many domains. And with just same origin policy alone, Amazon.com can't read AWS.com data in the browser, right? They're different origins. The browser says, bah, go away, right? So with CORS, what we can do is AWS.com can, for example, send a header with each response saying like, hey, Amazon.com is on this list who can actually look at this response. So when we ship this thing to Amazon.com, it can actually look at that thing and render that HTML page. But if we send that response to evil.biz, evil.biz is not on that list. So the same origin policy as it was before says like, nope, this is cross origin. You can't look at this particular thing, right? So it's superficially very simple. The idea is when the browser sends an origin header, we essentially have the dual coming from the server to the browser saying like, hey, this is the origin of the thing that's allowed to look at this response. So for example, aws.com would specify this origin if it wants to let amazon.com look at that response. If it's completely public data, like say, the NOAA data for weather, you can say like anybody can actually access this thing. Now, unsurprisingly, web developers sometimes opt in for wildcard, even though they might mean something like, Amazon.com, something more fine-grained, because this always works. But you're also potentially exposing sensitive data to origins that you otherwise would not want to. Now, one thing that differs between CORS and JSONB is that we may actually send cookies and custom headers to the server to let it decide whether or not it wants to send a response. This is a little bit more complicated, but it's basically one way of making sure that not only are you sending it to the right origin, but you're sending this response to the right user cross origin. Okay, the last one is a permission policy. This is something super duper new because web apps can request all kinds of fancy data like cameras, geolocation, battery, so on and so forth. We now have another header that can, again, restrict either pages or iframes from accessing this sensitive information and then, having allow lists saying like you're allowed to actually access this thing or not. Okay, so with that, I will let you go and just bring back the original slide that looks at the questions that we were trying to answer. And hopefully, if you need to deal with any of these attacker models later in your work, this can serve as a reference to many other things. Okay, thanks so much. And I will not see you Wednesday. I think Wednesday we are off, but I will see you on Monday. My old hair was a disaster, but thank you.